Most of the time when people are looking at a number line and trying to discover the midpoint, one of the ways that they do it is they take and they start at each point and they just kind of count in simultaneously from each side and recognizing that that midpoint is at 2. However, if we look at the numbers -2 and 6, which are the two endpoints, the numeric relationship between -2 and 6 and this midpoint is that if you were to average them, so you're going to add them and divide by 2. If you were to take the average of those, that midpoint 2 is indeed the midpoint that we came up with by looking at the picture. So when you look at a number line, you can either count in or you can take the average of the points. Now, when you extend that concept to a graph, it's the same concept. We could take and we could look at those and kind of just move towards the middle of each of those points. However, it's easier to go ahead and identify which coordinates we're looking at. So we have -3, 4 there, and then we have 2, -4 here. So then if I look at this, what I'm going to do is I'm going to take the average again, but I'm just averaging the x coordinates. I don't know why this one didn't do blue, but that's okay. -3 plus 2 divided by 2. And then I'm going to also do the average of the y coordinates. Here we've got 4 plus a -4 divided by 2. And so when we look at this, our midpoint is going to be -1/2, 0. And if I were to take a look and draw in the segment that connects those. If I were to draw in the segment that connects those, now when I look here, it's obvious that that -1/2, 0 does lie on that segment. So that's a quick refresher on midpoints. Again, all you're doing is averaging the x's and averaging the y's. Okay. Another way that we have seen that in the past in geometry is you x1 plus x2 divided by 2 and y1 plus y2 divided by 2. That is the way that you find your midpoint. Now, when you're looking at distance, okay, it is directly related to doing the Pythagorean theorem. So when we look here, if we're doing Pythagorean theorem, we would do 6 squared plus 6 squared equals our unknown squared, and we would have, I don't know what that happened there, sorry about that. We'd have 36 plus 36, and we'd get 72. And then if we did this and we broke it down to get a simplest radical form, we would end up, we do 36 and 2, that's done. 6 and 6, that's done. I can use that because I have a pair here, so it becomes 6 root 2. If I wanted to get the numeric answer, obviously I could and not have to worry about the simplest radical. I could just do the square root of 72 in my calculator, and I would get approximately 8.49 if I went 2 decimal places out. Now, when you do the distance within a coordinate plane, it's the same concept. So when you look here at this example, we are going to be finding the distance from A to B. Now with that, when you find the distance from A to B, you could think of this triangle that I have sketched here as being drawn in. But what I'm going to do to find the distance from here to here is I'm going to find the difference between my x values. So the difference between my x values is 6. When I look at my y values, again, to find the distance from here to here, I'm going to do the difference of my y values. So between 4 and -2 is also 6. And again, now I'm back to what I did in the previous screen. I have 6 squared plus 6 squared equals x squared. And when I solve, I would get x equals 6 root 2. Or again, that decimal that I had previously of 8.49 when I were to solve for that. Now, again, if we're looking at a formula and wanting to have something to reference back, the way that we found the distance between our x's, so this length here, is we're going to subtract. So you have x minus x, and then you would do the same thing vertically, except for you're going to do the y's. And then if we think about it being connected to the Pythagorean theorem, notice we have to square those pieces. We also have to add those pieces. So we're going to add those, and that's going to equal your distance squared. So to get the distance by itself, we're going to do the square root. And that is your distance formula that maybe you have seen in a previous class. The only other thing that you need for today's assignment is the equation for a circle, which is also directly connected to the Pythagorean theorem and also to the distance formula. So your equation of a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals your radius squared. So again, you notice you have the subtraction inside the parentheses, the squares outside, we're adding. It's all directly connected to your distance formula. So your h and k represent the center, and the r, since we're talking about a circle, the r represents the radius. So as we're looking at an example here, write the equation of the following circles. Your center is 4, 0, so you have x minus 4 squared plus, and then you have y minus 0, but y minus 0 is just y, so we don't have to worry about the minus 0 part. And then it equals your radius squared. Well, we know the radius is 3, so 3 squared gives us 9. When we look at the next one, it's the same concept. I don't know why it keeps doing that, so I apologize. Hold on 1 second, let's move it back. Okay, so when we look at the next one, your center is negative 1, 7. So, come on now. Guys, this is technology for you, I'm sorry. So we have x. If it's minus and negative 1, it's going to turn into a plus 1. Again, we're going to square it, and then y minus 7 squared. Now notice they give you the diameter instead of the radius. Your diameter is 20, your radius is then going to be 10, and when you plug that in and you square it, that's going to be equal to 100. Now, number 3 is a little bit different, because number 3, they don't give you the radius. They just give you the center and what it passes through. So you've got x minus 6 squared plus, and then you have, again, y minus a negative, so it turns to plus 2 squared, and we don't know what that equals, okay? But what we do know is that we have that it passes through the point 3, 4. So what we can do is this is an x value, and this is a y value. So this is a 3 here, and this is a 4 here. So if I'm looking at this numerically, 3 minus 6 gives me a negative 3. And then 4 plus 2 gives me a 6. And I can solve this left-hand side. So negative 3 squared gives me 9. 6 squared gives me 36, which is then 45. And that is what this equation is going to be equal to. It's going to be equal to 45. Now, there are other ways to solve this, but using that substitution, since you know the x and y, using the substitution, using that point, makes it the easiest, because then it's just going to be equal to that number. Okay, so hopefully that helps a little bit. Obviously, we're going to take some time for questions if you have them, but hopefully that at least gives you a quick review of some of the stuff that you may see today.